All right, good afternoon. We've made it to our last session of ML24, and I'm very happy to introduce you to work by my Jane Street colleagues, Chris Casinghino and Ryan Tjoa. This was actually Ryan's intern project, which I think is pretty cool. And I'm not going to tell you what it is. I'm only going to tell you that I use it a lot and I like it very much.
Thanks very much. Is working? Can you hear me? Yes. Okay. Sorry? Too quiet. Can you hear me? No? Can you get the...
Better. Switch that.
Does that work? Can you hear me now? Yes, I'm getting thumbs up. Okay. All right. Yes, I'm going to talk about labeled tuples. This is a small feature we added to Jane Street's branch of the OCaml compiler, but I think there's a few interesting things to say about design choices and also comparisons to similar features in other languages like SML's flex records. So I don't know. I think it's fun to talk about a little bit. And as Jesse mentioned, this is work Ryan did on his intern project. Ryan actually just joined us full-time last week, so send your interns to come work with us. They can do fun things like this. Okay, labeled tuples. So let me start by explaining what this is. I mean, it is what it sounds like, but I'll show you a few examples to get started. Okay, this is a function that computes the sum and product of a list of integers. It does that by folding over the list and accumulating a pair containing the sum and product. And there's nothing that surprising here except there's labels on the tuple. So we define the initial value using a tuple that has labels on the two fields indicating which one is the sum and which one is the product. And then we fold over the list, and there's the function that we're folding over takes a labeled tuple as an argument and uses a pattern to get out the sum and product fields. That pattern is pun, just like a record pattern can be punned. And then we update the sum and product for the current element and return the new sum and product, again using a pun. So what is the point of these labels? The point is to help you avoid errors, right? If you accidentally mixed up the order of the sum and product in the initial value relative to the folding function, you would get a static error. And similarly, if you mixed up the value of the arguments to the function in the tuple relative to the value you're returning, you would get a static error. So it just helps you keep track of which values are which in your program. So this example shows labeled tuple expressions in the initial value and the return of the function, and labeled tuple patterns in the argument of the function. There's also labeled tuple types, of course. This is what a labeled tuple type looks like. It looks like a tuple type. This is the type of the function f that's being folded here, and its argument and return are labeled tuples, and those look like tuple types but with labels. Okay, not rocket science. There are a few twists. We support a certain amount of reordering and partiality and pattern matches. So here I'm defining a labeled tuple, which is a pair of the integers x and y, called LT. This is an example from the OCaml top level. And then I want to get twice y. So I can do a partial pattern match on that LT and get out just the field named y by using the label. And then I multiply it by 2. And this works fine. This works as long as the compiler knows what the type is of the pattern that is being matched on. It needs that type information to do this kind of partial pattern match, because otherwise how do we know where the field y is in the record? So if the compiler doesn't know the type of the thing that's being pattern matched on, you're going to get an error like this. So in this case, I've written a function that tries to get y from something t that we don't know the type of. And so we try to do a partial pattern match on t, but the compiler doesn't know the whole type of the t tuple, so it gives you a static error saying, I don't know what the type of this pattern is. This may be surprising depending on which functional languages you're familiar with. I think it feels pretty at home in OCaml, where type information is used in a couple different ways in this kind of situation. It's used to do like disambiguation of constructors, but more relevantly, it's used to make type checking of labeled function arguments nicer. And so this is pretty well at home among those kinds of features. Okay, a couple other features that we've added. Not every field in a tuple has to be labeled. So here I've got a triple. It's got, maybe I've computed the min, max, and average of some data structure, and I've chosen to label only 2 of the fields, the min and the max, because those 2 have the same type, and maybe I want to keep track of them. Whereas for the field that's a float, it's more obvious which one is the average. So this is supported. In fact, under the hood, the way we added this to the compiler is that all tuple fields just have optional labels. There's not like separate labeled tuples and regular tuples. It's just every tuple field now optionally has a label. You can also repeat labels. So don't write a tuple that looks like this, but it is supported by the compiler. This is a 5 tuple, and it's got 3 fields labeled x, 1 field labeled y, and 1 unlabeled field. And then if you do a pattern match on it, so here I've done a pattern match where I get out the first two fields labeled X. So the way that works is I've written 2 fields named X, so that's going to get the first 2 out when it does the pattern match. And in this case, that's 1 and 3, so this sum adds up to 4. This may seem like, I don't know, a misfeature or something, but we think it's nice to have. You can imagine having a tuple where the things fall into 2 different categories, and you want to give like label A to some of them and label B to some other ones. Also, it's analogous to labeled function arguments in OCaml, which, of course, you can have a repeated argument name. It's more necessary in the case of labeled function arguments to support currying, but I think this feature is very analogous to that feature in ways I'll talk more about later, and so it makes sense to have for this feature. Okay. So that's the feature. Hopefully it made sense. You may ask, like, why should we add this thing to OCaml? OCaml has a perfectly fine labeled product type. It's called records. What do we need label tuples for? So I think there's 2 reasons to add label tuples to the language. The first one is, OCaml has these labeled function arguments, and that's like a convenient way to, give a cheap name to parameters in your program. But there's a missing dual to that, which is like a cheap way to give the name to parts of values of your program. OCaml just doesn't have a thing to let you do that cheaply, and label tuples are that thing. And so in some sense, it feels like a missing dual to labeled function arguments. And many of the implementation choices I'm going to talk about later are motivated by that understanding. Also, like, just from a practical perspective, people don't use records as much as they should. Sometimes when you're defining you've got 3 things, you need to return them from a function, and they're only going to be returned from this function and used in one other place. It feels like overkill to define a record, a new type for that one purpose, and so people don't. This is particularly true if your style guide says, oh, when you declare a type, you should add a printing function for that type, or maybe a serialization function. Maybe it should belong in its own module. Those kinds of things add burden to declaring new types, and so it can be nice to not have to declare a new type and just get some labels for free. So, of these 2 reasons, I would call the first one the primary reason we did this. It feels like a missing feature in the language once you start to think about it. But the second one is kind of more fun to talk about. So let me show you examples of some code that people write because they don't have label tuples. So here's one example. This is a function from the core Unix library, which is a library Jane Street maintains, and it creates a new pipe, and it returns 2 file descriptors. Now, one of those is for writing, and one of them is for reading, and I'll let you make a mental guess about which one you think is which. But this is sad. In fact, the comment for this function doesn't even really make it super clear which one is which. So that's bad. They could declare a record that has 2 fields, one called read and one called write, and that would make it clearer, but that felt like overkill to the author of this code, and so they didn't do that. And that's sad. So don't write code like that. Write code like this that makes it clear using a label tuple that the first one is for reading and the second one is for writing. Sad example number 2, polymorphic variant. So this is a thing people do kind of surprisingly a lot. This is an example pulled from Jane Street's code. So here, they're defining a tuple, and they've used polymorphic variant constructors to label the pieces of the tuple. They've got a price and a size, and they don't want to mix up how much something costs with how many of them they have. And so instead of constructing a tuple of price and a size, they've constructed a tuple of polymorphic variants containing a price and a size. This you can do. I personally think it looks a little ugly. It also begs questions like, okay, are these variants intended to have more constructors? What was the intent of this code? And also, there can be a dynamic cost. So if I get lucky, if this definition is very local in this file, and Jacques just gave me a shake of his head. If I'm lucky and this definition is very local in this file, then the compiler will eliminate these, do this unboxing for me. But these polymorphic variants do correspond to a box at runtime. And if, for example, I construct them by calling a function that doesn't get inlined, then this has a genuine runtime cost compared to the thing you should write instead using a labeled tuple, which has no runtime cost. Okay. Sad example number 3, you could build a whole PPX to get around this problem. So this is something somebody actually did inside Jane Street. They wrote a thing called PPX anonymous records. Now, a PPX is a preprocessor that's supported by the OCaml ecosystem. It's a source-to-source transformation. And they wanted essentially the equivalent of labeled tuples, so they built a PPX for that. So the way this works is this is the same example from the first slide, but using their PPX. This %anon thing, that's on line 2, that's an anonymous record expression, and the %anon question mark thing, that's an anonymous record pattern. And so you could do this. This has some downsides. I think it looks very ugly. Also, in the initial implementation, it had some runtime costs. They did eventually eliminate those. But lastly, using a PPX, it makes it less clear what code you're actually running because this is going to get transformed by some arbitrary program. And because it's a source-to-source transformation that doesn't have access to any type information, it can't do some of the things like partial pattern matches that we saw on the previous slides. So it's a worse feature in that sense. So don't do that. Write it using labeled tuples like we saw on the previous slide. Now, some of you may be thinking, OCaml already has a anonymous, a structurally typed product that you can just use in your programs, and that's the class system or the objects. So that's true. You could use objects to build a sort of cheap record where you label the fields of it, and you don't have to declare it ahead of time, so it eliminates that cost. I think in practice, the object system in OCaml is not super widely used. I don't have any examples to show you of people doing this in our code. Maybe some exist. People do occasionally use objects, but it's mainly when they want open recursion. That's the main use case we see for the object and class system. So you could use objects, but again, like the polymorphic variant example, and even more so, this is going to have a runtime cost relative to just using a tuple. Objects do have some overhead to do like lookup of the fields at runtime, and so that feels worse in a high-performance system. Okay, so don't do that. Use labeled tuples. So that's motivation. Let me now turn to talking about some of the design choices and some related work like flex records. So a choice that we made, and which I talked about earlier, is limited support for like reordering and partial matches. In particular, the compiler has to know the type of the thing that you're matching on in order to give you the nice behavior where the fields are reordered. And we could do something else. We could use row polymorphism to give these like really general types and just do inference that way. We didn't do that, and we think that's the right choice, and there's a few reasons why. The first reason, the obvious reason, is implementation complexity. This is a very small change to the OCaml type checker to add these labels, and we got it done reasonably quickly and deployed it, and it's useful, and we don't have to add. I mean, OCaml, of course, has some infrastructure for row polymorphism because it's used in the type checking of polymorphic variants and the class system, but we don't want to add more of that. It adds a lot of complexity to the implementation. Also, that kind of implementation would probably come with some runtime overhead, like objects do. And we wanted these to have performance equivalent to tuples. And lastly, this version is more analogous to labeled function arguments, which, as I said, sometimes make use of type information to be type checked more conveniently. And I think that's really the main reason. We're really thinking about this as a value dual to what labeled function arguments give you for parameters. It's a small change. That feels nice. There's a secret fourth reason, which is that if we make this too nice, people will use it too much. So OCaml does have records, and you can use records, and you should use records, right? You should declare, if you're going to have a type that's used by many parts of your interface, you should declare that type, give it a nice name, write down functions that do like printing and serialization, and we don't want people to stop using those types. Those are great. They should use those more. So by making this a cheap feature that has good behavior locally, but maybe is not as convenient as records globally, we encourage them to use records when that's appropriate. Okay. Also, one thing to say is, I think these choices are reasonable, in particular because this has proved to be very popular. So here's a message that we got sent on Slack shortly after shipping this. I feel very good about this. I've blocked out this person's name for privacy reasons. And ironically, they got the name of the feature wrong. It's labeled tuples, not named tuples, but that's fine. But people are generally excited about this. Not everybody was so easily convinced. Some people at the firm needed a little bit more convincing. But even the most stubborn folks came around eventually. And these are not the only sus messages we've received. It's very popular. It's used in thousands and thousands of files in our code base. I think it's gone over pretty well. Okay, so flex records. Surely there's some standard ML people in the room, and they're thinking, SML has this. What are you doing? Why is this interesting? And that's true. Labeled tuples are very much like SML's flex records. There are some differences. One difference is that we support these omitted labels and these repeated labels, which feel more natural in a tuple setting than a record setting. But I think the biggest difference is just that flex records are canonically ordered. So these two types in standard ML, which are records containing an integer y and an integer x and a Boolean y, in two different orders, are the same type in standard ML. And the way they get represented at runtime depends on the names of the fields. So they get sorted alphabetically, so the x is going to come first for both of these. And that's a choice you can make. We prefer to leave these as two different types, mainly because sometimes people write performance-sensitive code and they care about the memory layout of their programs. And so we want to give them the ability to express the memory layout that they want. And by making these two different types, we give them that ability. Also, I'm going to continue to say this version feels at home next to labeled function arguments, which also, like a function that has several parameters with the same names, the two function types are different if the order of the arguments are different. Okay, so I submitted this as an informed position talk. Maybe I should have some kind of position about this feature. And my position is not that this is like fundamentally better than Flex Records. I think it's extremely similar to Flex Records. They're both fine features. But my position is that a language like OCaml has room for both a structurally typed labeled product like these tuples or Flex Records, and a nominally typed labeled product like OCaml's declared records. I think these don't crowd each other out. It feels pretty natural when to use one or the other, and by making one of them tuples and one of them records, they kind of fit next to each other syntactically just fine. So my position is it's great to have both of these in your language. Okay. I want to take a divergent down some history. So after we realized we had basically just re-implemented Flex Records, I was like, oh, how did that end up in SML? What's the history there? As far as I can tell, there's no papers really just about Flex Records. But I did find these notes from 1985, written by Bob Harper at some SML meeting in Edinburgh. And these are like on the SML of New Jersey website, and they're great. So one interesting thing about this meeting is that they were debating what to do about a labeled product, and they were debating whether to call it labeled tuples or flexible records. And at that time, they weren't really sure what to do, and in fact, they weren't really sure whether to include it in the language because they hadn't figured out how to do the type checking yet. I don't know what happens after this. I don't know how Flex Records ended up in the language in the form they did. I would love to know that. If some of you know, I want to hear about it. But I think this is interesting history. And I would really recommend reading these notes. They're like 10 pages long. They are just a great read. You get a look into how people were thinking about functional programming language design in 1985. Also, they're extremely relatable. If you've ever argued with anybody, about language design, I think you'll feel right at home reading these notes. Okay. Okay, just to conclude, and I'm sure I'm way under time. Yes, to conclude, what else could we do with this? We haven't actually implemented a projection for these. It's not super necessary because you can do the pattern match where you pull out one field. We could implement it. It's a little inconvenient syntactically because the most obvious syntax for projection is already used for records. So we could either use a worse syntax like .twiddle or something, although maybe that's used by OCaml, or we could make it type-directed, which thing you're getting. Both of those feel kind of crappy, so we haven't done this yet. People haven't asked us for it that much. What people ask for all the time since we've shipped this feature, like once a week, is singleton labeled tuples. Basically just the ability to add a label to an arbitrary value in their program. This surprised us a little bit, and also it's kind of hard to do just syntactically. Like if you've got f applied to twiddle x, is that f applied to the labeled argument x, or is it f applied to the unlabeled argument, which is a singleton labeled tuple? Now, that can be resolved with parens somewhere, but it feels a little gross, and so we haven't done it. Also, okay, then if you start continuing down thinking about this, you might think, oh, well, actually, maybe I can just replace both labeled tuples and labeled function arguments with singleton labeled values and get rid of both of those features. But this doesn't work at all because labeled function arguments support nice reordering and partial application in a way that these singleton labeled values would not make easy to do, at least as far as I see. So we haven't done that. One thing we are considering adding, though, is labeled function returns, which I think do most of the use cases that people want these singleton labeled values for and would feel right at home next to labeled function arguments, I think, in OCaml. Okay, I think that's everything I have. Thanks for listening.
Thanks for your talk and for the cool feature.
Sure.
If one of your design considerations was that you wanted tuple syntax to be similar to that for function parameters, was there anybody who really wanted question mark and equals and some of the other stuff?
Yeah, we have had some requests for optional tuple parameters. This doesn't feel, I'm not sure I see a fundamental implementation obstacle, but I basically think, sorry, Jacques is sitting right there. I kind of think optional parameters are a misfeature, and I would remove them from the language. Although I love labeled function parameters, so I'm not super inclined to build this. I think there's a lot of bugs because of optional parameters, right? You forget to fill it in when you're supposed to, and I'm not inclined to give people that power more often. Does that make sense?
Absolutely. Thanks.
First question, since the named tuple are more structural, did you enable recursive types without rec types?
Did I enable recursive types? I didn't add any special support for recursive types. I think you can define a recursive type including a...
So if you didn't enable them, probably it's these are without rec types, because polymorphic variant and object support recursive type without the explicit option.
I think it just works, but I'm not actually sure. We could try it out later. I'm not sure what we'd implemented, to be honest with you.
Yes. And then Gabriel Scherer had a question online, and he was asking if he thinks that repeated labels are a missed feature. So he was wondering what happened if you disable the feature.
Sorry, I missed the last part of that. What happens
if you disable the option to have a repeated name?
Oh, nothing particularly bad happens. We don't have to have that. As I say, functions have this, right? So it feels natural. I'm not sure if it's used at all. This would be easy to find out. This would be a fun thing to find out. I don't know. One other reason that we wanted to have that is because, I mean, really under the hood, the unlabeled fields all share some unique label, right? Some unique anonymous label. And so, like, you can do a pattern match on a tuple where you just pull out the first anonymous field, and that works fine. And so they feel pretty analogous, if that makes sense.
Thanks.
Sure.
Hi, thanks for the nice talk. So maybe as a little bit of validation, it's interesting to point out that they're basically implementing the same thing in Scala right now. They're working on the same feature. In Scala, there are a lot of interesting things that come up, like which subtyping relations should these things have. And actually, this could be applicable to OCaml as well. Like, can you coerce a named tuple into an unnamed tuple? You could support that, right?
Could we support that? Yeah, that would work fine. I'm not sure I see a big... So OCaml, do you know about the no labels flag? OCaml has a flag that you can pass to it where, like, it just forgets all the labels. Like, we could make label tuple support that almost, except for the reordering and partial patterns, it would be hard. But a coercion to an unlabeled tuple should work fine. I mean, the labels are eliminated immediately after type checking in the translation to OCaml's lambda IR. So they're not doing anything. It would be easy to build a coercion. Yeah.
Right. So they should be able to support this sort of subtype coercions.
Yes.
Thanks.
Did you say that you could sometimes pattern match in a different order?
Yes.
But you also said that you don't want labels to commute. You want them to be different types. So I'm kind of confused with both assertions together.
Sure. So if the type checker knows the type of the pattern, then it can do the matching up for you. So if we know the type of the pattern, we just when you write the pattern, we like match up the fields with the way we know it's going to be laid out at runtime because we know the type of the pattern. This is very similar to the way function arguments.
I understand how you can do it, but when you say you don't want labels to commute, you want them to be different types because you don't want to have confusion.
Yes.
But now you say if I know the type and I put in different order, I say okay, it's okay. So.
But only in the pattern, right? We don't allow any reordering of expressions. So even if we know the type, you cannot reorder the expression. It feels a little convenient to us in the pattern, but maybe that's a mistake. I'm not sure.
So the other thing you said is that if you use flex records, they would not be as efficient.
No, I think flex records are equivalently
efficient. But I think
efficient.
if you put the same restrictions that when you don't know the types, you disallow them.
Yes,
it would be the same efficiency, I guess.
That's right. If I said that flex records are less efficient, then I misspoke. They're the same efficiency at runtime. So I'm sorry if I misspoke. Yeah. I think like objects would be less efficient. A version that used row polymorphism would be less efficient, which flex records don't use. All right, thank you.